Space. It is huge, mysterious, and full of wonders that we are still learning about. Wormholes are among those wonders. Are they real? Or are they just physics and math masked as magic? And, if they exist, how do they function and where can we locate them? Let's start with the fundamentals. A wormhole is essentially a shortcut through space-time. It connects two distant points in space. Consider folding a piece of paper in half and poking a pencil hole through it. That's sort of how a wormhole appears. Wormholes are also known as Einstein-Rosen bridges, named after the physicists who first proposed their existence. The term bridge is used because wormholes create a connection or a bridge between two different points in space-time. So, for instance, if you wanted to go from New York to London, you could take a plane and spend hours in it. Or you could travel almost instantly by using the wormhole as a shortcut. Doctor Strange is the best example of it. I hope you all heard of him. In the Marvel's movies, whenever Doctor Strange wanted to go somewhere, he used his hands and opens a portal. That portal is the wormhole. But this is where it gets complicated. We need something called exotic matter for this shortcut to operate effectively. Exotic matter is a hypothetical type of matter with a high negative pressure and negative energy density. It's crucial to remember that antimatter and dark matter are not the same thing as exotic matter. The Casimir effect produces a region of negative pressure density, which is the closest known real representative of such exotic matter. A physical force that affects the macroscopic boundaries of a confined space is known as the Casimir effect. It was predicted for the first time in 1948 by Dutch scientist Hendrik Casimir. Quantum vacuum fluctuations, which are fictitious particles that appear and disappear in void space, are the cause of the effect. According to one of some theories, exotic matter, a fictitious type of stuff with negative energy density, could be used to stabilize a wormhole and prevent it from collapsing. The existence or creation of exotic matter is unclear, though. Another theory proposes that by manipulating the fabric of space and time, it may be possible to create a traversable wormhole without the use of exotic matter. It would require a better understanding of gravity's laws as well as the ability to manipulate space and time in order to create a wormhole. Astrophysical wormholes are hypothetical non-trivial topological structures that may exist in our universe. To keep these structures stable, some exotic matter with negative energy density is required. But here's where things get even more complicated. Wormholes are extremely unstable and would likely collapse almost immediately if not stabilized. One possible stabilizing force is gravitational waves. These ripples in spacetime are created by practically everything in the universe, from the ambient remnants of the Big Bang to the explosive deaths of stars.
We interrupt our program to bring you this important message.
I've taken space and folded it over so that this region over here is close to that region on the diagram. These two places are very far apart. The new thing, because they're entangled, is that an Einstein-Rosen bridge forms between them. An Einstein-Rosen bridge is popularly called a wormhole. It's a route through space which short-circuits the long distance between these. This is, to my mind, one of the craziest things we've discovered in the last 20 years. That the existence of entanglement creates spatial connectivity between two regions which would otherwise be very, very far apart.
In their experiment, researchers showed that they could keep a wormhole open for a sufficient amount of time by applying negative energy shock waves, which would create a kind of gravitational wave that would act as a stabilizing force. So that's everything that you need to know about wormholes. While they are still a theoretical concept, the existence of wormholes could revolutionize our understanding of the universe and the possibilities of space travel. Thank you for watching. It was a short video about wormholes. If you want a longer video about wormhole, let me know in the comment. And I hope you enjoyed this video. If you have any questions, please feel free to leave them in the comments section below. See you next time.
See you, pals.